Hello, and welcome to the Current Science and Technology podcast from the Museum of Science in Boston. I'm your host, Susan Heilman, and every week we bring you interviews with guest researchers and our museum staff covering science and technology in depth. Nano Days has once again come and gone, and I was able to speak to a number of scientists, researchers, and other nano-interested people. Today I have with me Larry Klein, a multiple Emmy award-winning Nova producer who helped make the movie From Lab to Fab, Pioneers in Nano Manufacturing. Thank you for joining me and talking with me.
It's great to be here.
So I guess one of the first questions is, what got you interested in making a nano movie?
Well, I was asked to make the movie by Carolyn Alpert here at the museum. I think Carolyn's been involved with nanotechnology for many years now.
Yep.
It's a pretty difficult topic. A lot of filmmakers shy away from it.
And why didn't you?
The thing about making a film on nanotechnology is you have two strikes against you immediately. One, people don't understand the complexity of the science involved, right. And two, you can't see anything. So you have two strikes and you haven't even come to bat. So it's a real challenge, and I kind of like challenges. I like to see if I can overcome that some way.
So were you able to come up with some of the solutions to the challenges, or did you also have, I'm guessing, a lot of help from the nano manufacturers?
Oh, yeah, I had a lot of help. This is really cutting-edge science, and it changes every day almost, or it feels like it. And we had to we researched this program for months. I don't mean weeks, I mean months. And we visited different researchers and people trying to move their nanotechnology from the lab bench to some sort of production mode. Mm-hmm. It was fascinating. We visited people working with quantum dots and making really interesting color TV.
Yeah.
I liked that one. But the thing about video, whether it's broadcast video, whether it's web video, whatever, I think it works best when it tells stories. And so one of the things that you get caught up in is the science. And the question is, how do you fold that science? How do you fold that information into an interesting story?
And you focused on two compelling and complementary stories, that of entrepreneur Peter Antoinette from NanoComp and engineer Ahmed Bousnena from NanoOps. And both of them are excellent speakers. And I think they partly have to be, because what they're doing is not just science, but they are also doing the business end. They're trying to start companies to take nanomaterials, which is, for the most part, it's often just made in a lab what you need. But if they want to sell it to people, or they need to scale it up, and to scale up something nano takes a lot of scaling.
A lot of people who have been working in this field for more than a decade now, they do some wonderful stuff on the lab bench.
Right.
You know, they can make things miraculously work, whether it's to conduct electricity or
change colors,
or whatever. Yeah. But to take that then into a product or into a process that can become a product is very difficult. I mean, if you think about it, the nanomaterials are so tiny, there's nothing around that can weave it together or pick it up or do anything with it. You have to find indirect ways to use these materials to make something, and most of the researchers are using the properties in the materials themselves to what they call self-assemble, so that they can form three-dimensional objects or threads or whatever they might be on their own, because it's very hard. It's very difficult to control it, and it's very difficult to do it precisely. And what manufacturers only want, whatever the product is, from a tennis ball to a TV set, is consistency. Right. They need consistency.
Every single one has to be exactly the same.
Exactly the same. So when we first started this project, Carolyn and I went to the person probably more responsible than anybody in the United States for promoting nanotechnology, Mihail Rocco at National Science Foundation. And we talked to Rocco about different ideas on the project. And it was interesting because one of the things that we mentioned, the nanotubes and how they're being used in products as one of the nanotechnologies that's gone into production. And Rocco said, well, that's old technology now. You should look at more advanced stuff. And, we did, but we kept coming back to what this particular group, NanoComp, was doing because it was very different from everyone else. And they were making materials entirely out of nanotubes. And these materials are really next generation products, those very thin sheets that can stop bullets.
The second story is about NanoOps, and they're making circuits and sensors reproducibly. They're just starting up. NanoComps has been around for a while. It was great to see the juxtaposition in the film. What do you think they can learn from each other?
Well, that's why we put them together.
Right.
One group has hurdled not all the problems. If you were to ask Peter Antoinette at NanoComp, is he over the hump yet, he would say no.
Oh, okay.
I mean, he would point to the expanded factory and the new contracts and all this stuff, but he would never feel completely like he's home free.
Right.
Okay.
But
the thing is that NanoComp spent a lot of time getting through that valley of death, which is a kind of a business term for that moment where someone has built a prototype of something or made a prototype of something that looks very good, and they need investment money or some big contract to get them into full production and go to that next stage. And Peter's done that. He hurdled that.
Right.
He got, and in fact, it was just that thin material. He got a big military contract for bulletproof vests.
Well, lightweight material.
Lightweight
and
material.
Bulletproof.
And with Ahmed's NanoOps machine, and I want to say, first of all, that this particular device is very rare because we talked earlier about how there are very few things that can work with nanomaterials.
Yeah.
So this is both a machine that can work with nanomaterials, and the process that is used by this machine contains nanotechnology on several different levels.
So using nanotechnology
it's
to make
both
nanotechnology.
using it and making it, and making things with it. Now, it is in fact a kind of a very portable, in quotes, desktop version of a chip factory.
Right.
Because it can make circuits, but it can also, right now, what it's actually doing right at this moment is making very tiny sensors on flexible material and plastics that are usable on so many different things, from testing whether there's chemicals in water or on your body.
Right, it can be used on biological
things.
Samples,
It's a really wonderful concept, but it's where NanoComp was 10 years ago. That's where we show its unveiling to the public, and now Ahmed and the team is waiting to see if they get investors.
So you mentioned the unveiling. I'll spend just a minute on that. So in watching the video, it's a 20-minute video, so it's obviously been condensed from what's going on. But the huge unveiling, Ahmed's out talking to people. They're saying, this is an amazing product we have. And at the same time that's going on in the movie, you keep cutting away to his colleagues and students who are setting up the machine for the big unveil. And all of a sudden they say, we've got a problem. Now, where were you in the film? Which side were you on? And was this really happening at exactly the same time?
It's all real. So there was a greeting area, a main room where Ahmed and the president of Northeastern and people gave speeches, to an assembled audience, and then they were going to be in groups taken back to where NanoOps was located. I was in the back trying to wrap up some last-minute shooting to rush to the front to get the speeches.
Right. Oh, okay.
I don't have multiple cameras here, so
okay.
All of a sudden we're about to leave, and I hear, "Uh-oh." And I look, and sure enough, the machine had stopped. So I had to make a decision.
Right.
Now, I knew another group was filming in the front of the room. So I said, okay, we have to stay with this.
Yeah.
Because this is what you do as a filmmaker. You look for opportunities to test people's ability to overcome problems.
Right.
So we stayed, and they're talking out front. I then reviewed the video, and if you could see.
I was going to say, because you do have a second camera. I mean,
there
is
is
a camera
another
out
camera.
there. Yeah.
If you could put a clock, you would see that these guys are desperately working to trying to get it to work while people are talking out in the front. And just as that first group is coming back, just as it's coming back, they got it to work.
And they're like, sure, everything's great here.
Yes, right.
How are you?
No one had a clue any of this was happening.
When did Ahmed find out?
Afterwards. So sometimes it's very hard to convince institutions, companies to show this process that always happens when you're doing something creative, where you hit a stumbling block. Most people, when they try to present videos, they only want to show you how wonderful everything is,
100% success rate every time.
Every time. Or it makes it feel, even if you use language, we work very hard and blah, blah, blah. At the end of the day, they don't show it, and they don't want to show it. They never want to show anything going wrong. And what you realize is that if you get that opportunity to show something wrong, or show a mistake or a technical glitch or something like that, but your team overcomes it, it actually creates a stronger impression.
It's more powerful, absolutely. Because if it had just worked, you'd be like, yay, it worked. Of course it worked. It was supposed to. But this way, you're like, wow, they were really, they didn't seem to panic, but they pushed through and they got it working right when they needed to.
Yeah.
And I thought it showed them at their best.
Yes. I'll tell you, Ahmed partners with this company called Melara, which is in Massachusetts. It's a brilliant robotics, precision mechanics company.
Right. That's what the machines themselves are.
And their team is unbelievable, and they have to be unflappable,
right?
And they have to be
keep their cool
and fix. And I'll tell you, Ahmed found a really good partner in them.
Yes.
What Ahmed has done with NanoOps is it's just such a bold stroke. I don't think people realize what he's taken. A process. These fab labs they're called, that produce microchips. We're down to 3 manufacturers in the world. These labs cost about $10 to $15 billion each. Even large companies, even IBM isn't making their own chips anymore. So you have to send it to these companies, give them the specs that you want. That means you're giving away some of your proprietary information. This machine that he's doing will allow little companies and big companies to, I believe, to really test their product out a little bit. I don't think it'll ever replace the volume of one of these $15 billion. Right. But it can really make a difference, I believe, in the long run. I'm not an expert. I'm not a technology guy. I'm just a filmmaker. And the process, this offset printing process that he used, is so simple in a way. It looks...
Sometimes
it took years.
Sometimes that's the best thing, though. The simplest answers are often the best solutions.
And everybody has worked very hard on that machine, so I do hope they achieve success with it. It's not work for the timid to do this sort of thing. You're investing years of your time.
And that's why I really liked, again, putting Ahmed with Peter together and telling those two stories, because you can see a similarity between them. And it'll be interesting to see if NanoOps does follow NanoComp in its success. And finally, Larry, what was the main thing that you enjoyed learning about with this project?
I think, to me, we've become so dependent upon the devices like cell phones and laptop computers that we use every day. And, we don't understand what's in those little boxes. We don't understand what's in there. And I still don't understand all the things in there. This project is getting me a little closer. But I started making films about older technologies, water mills and things of that sort, where the mechanics are visible to you. You can see the wheels turn and
Right.
the gears move and whatever. But once you bury that stuff in little boxes and smaller and smaller and smaller internal devices, it becomes more magic rather than giving people a sense of how things work. And I actually wish that wasn't the case. You know, that understanding of, oh, yes, that's why the gear does that. You know, that's the challenge with electronics, and the challenge gets harder as you get down to the nanoscale to understand the way things work. And this project, for me, got me a little bit closer.
And everyone can see the movie From Lab to Fab, Pioneers in Nano Manufacturing on our website at mos.org/lab to fab. Thank you, Larry, for talking with me today.
Thank you.
That's it for this week's show, but be sure to come back next time for more of the latest in science and technology. This podcast is a production of Current Science and Technology at the Museum of Science in Boston, part of the Boston community for over 175 years. For more information, visit our website at www.mos.org/CST or email us at podcast@mos.org. Thanks for listening.